Good morning, student. Myself, Mukesh Yadav from Yes Convent Senior Secondary School, Sultanpur. Today, my topic is nuclear size and nuclear density for class 12th. Now, we discuss on the topic of nuclear size. Student, I have clearly know that the atom have a nucleus and around the nucleus electron revolving. Now we discuss the topic is nuclear size. Nuclear size. The nuclear size means the radius of nucleus. We know that atoms contain a nucleus. In this nucleus, we know that we have two elementary particles named proton and neutron. We obtain the size of this nucleus. How the size, and we have clearly seen that the shape of this nucleus is sphere. The shape of this nucleus is sphere. Now, and the total mass of the atom contains in the nucleus. It means we say that 99.9% mass of the atom contain the nucleus. And in this nucleus, we have two nuclear particles known as which particle is proton and neutron. Proton and neutron. And this nuclear particle is called nucleons. This nuclear particle is called nucleons. In short, it is known as nucleons. If any questions about the nucleus contain nucleon. Nucleon, the shape of the nucleus is a sphere and its total mass of the atom contain the nucleus. Now, the size of nuclear, we know that the volume of the nucleus is directly proportional. The volume of the nucleus is directly proportional the atomic mass. That is, the value means V is directly proportional to atomic mass A. In the atom, we know that if any element we have just like X, then Z is represented the atomic number and A is represented the atomic mass and ZX is represented the name of the element. So A is the atomic mass and atomic mass is we discuss in this way. The volume of the sphere means we know that the nucleus is in the shape of sphere. So the volume of sphere is 4/3 pi r cube. 4/3 pi r cube is proportional to A, means atomic mass. So we write this R is cube is proportional to, we can write it 3/4 pi r pi A, and also we can write it R is proportional to A ki power 1/3. A ki power 1/3. A ki power 1/3. So R is equal to R naught. Here R naught is the proportional constant, A की power 1 by 3. This R naught is called proportional constant. Proportional constant, and its value is determined. R naught is equal to 1.2 into 10 to power minus 15 meter. Minus 15 meter. So, as a scientist study about the nucleus and name this scientist is Fermi, and 1 Fermi is equal to 10 to power minus 15 meter. So the proportional constant R naught is equal to 1.2 into 1.2. In the place of 10 to power minus 15, we can write the Fermi. In the place of 10 to power minus 15, we can write the Fermi. In short, Fermi is written as Fm. So R naught is equal to 1.2 Fm. Fm. Student, we have cleared that the volume of the nucleus is directly proportional to the atomic mass, and this is the perfect relation for the radius of nucleus and the atomic mass. If we solve equations or numerical on the basis of nuclear size, we take equations. We take equations. A element which have atomic mass. Yeah, we can say that element, a carbon, we can take the carbon, and 6 is the atomic number and 12 is the atomic mass. Then find the radius of the nucleus of carbon atom. We solve this numerical. Here given out. Firstly, we find out the atomic mass. Atomic mass is given out here 12 AMU. Atomic mass A is equal to 12 AMU. We can convert it 12 AMU into 1.6 into 10 to power minus 27 in kg. So the radius of carbon atom means the nuclear radius of carbon atom is equal to R naught means 1.2 into 10 to power minus 15, and atomic mass of the carbon is 12 into 1.6 into 10 to power minus 27 की power 1 by 3. So finally, this way we can conclude that the radius of carbon atom, and on this basis the relation between atomic mass and size of the nucleus, we conclude a result. The relation is R is equal to R naught A की power 1 by 3. R is equal to r naught a की power 1/3. Now we discuss a new topic is nuclear density. Nuclear density. Nuclear density. Student, we have imagined that let us consider a atom have nucleon, the mass of nucleon is m and the mass of nucleon is m and the atomic mass and the atomic mass is A. The atomic mass is A. So the mass of the nucleus, nucleus capital M is equal to M into A, and we know that the volume of the nucleus is equal to 4/3 pi r cube. 4/3 pi r cube means V is equal to 4/3 pi r cube, and we know that the density of nucleus is equal to mass of nucleus upon volume of the nucleus. We discussed the above. The mass of nucleus is equal to m into A upon the volume of the nucleus is 4/3 pi r cube. 4/3 pi r cube. In the previous topic, we know that the size of the nucleus is r is equal to r naught a की power 1/3. Putting this value in this equation, the density of nucleus is equal to m into A upon 4/3 pi. In the place of r, we write the r naught into A की power 1/3 means r naught A की power 1/3 and whole cube. So we solve it. Rho is equal to m into A upon 4/3 pi r naught cube into A की power 1/3 into 3 means m A dot A upon 4/3 pi r naught cube into A. So A and A is cancelled out, and finally we get rho is equal to m into m upon 4/3 pi r naught का cube means 3 m upon 4 pi r naught q. This is the perfect formula for density of any nucleus. This is the perfect formula for any nucleus. And for hydrogen atom, we find out the for hydrogen atom we find out the density of the nucleus for hydrogen atom, and it is in this way we conclude that the density of any atom's nucleus does not depend on atomic mass A. Student, from this relation we get the density of any nucleus does not depend on the atomic mass. So for hydrogen atom we know that for hydrogen atom we know that in the hydrogen atom the number of nucleons means mass of the nucleus is equal to the mass of proton because the hydrogen contain only one nucleon, means proton is 1.67 into 10 to power minus 27 kg. So we finally conclude that, and R naught is equal to, we have find out 1.2 into 10 to power minus 15 meter minus 15 meter. So we calculated that the density of hydrogen atom rho is equal to 3 into the mass of proton, means nucleons, is equal to 1.67 into 10 to power minus 27 upon 4 into 3.14 into the radius, yani ki the constant, proportional constant R naught is equal to 1.2 into 10 to power minus 15 meter whole cube. And finally we have solved that, and we get 2.2 into 10 to power 17 kilogram per meter cube. This is the unit of density. So from this conclusion we know that the density of nucleus is more greater. It means we compare this density with water. This is 10 to power, because the density of water is equal to 10 to power 3 kilogram meter per cube, and the density of this hydrogen nucleus is 10 to power 17. It means it is greater than 10 to power 14 times of the hydrogen atom, water atoms. Means it is more denser than water and other substances, other materials. So thank you, have a nice day, and